June 6, 1944. For 31 hours. The channel was a churning mass of gray water and iron. Waves pounded against hundreds of steel hulls as the largest armada in human history crept toward the French coast. Rain mingled with salt spray, and beneath the fog, engines rumbled like an approaching storm. Somewhere between the rolling waves, a new kind of vessel surged forward, its flat bow slicing the water with unnatural calm. It looked crude, almost unfinished, yet inside it carried something that would shatter the very foundations of German coastal defense. Tanks, ready to drive straight from sea to sand. The men on board could barely see 10 meters ahead. Their helmets glistened with mist. Radios crackled in static bursts. An officer shouted coordinates drowned by the wind. But the crews of these vessels, landing craft, tank, or LCT, were not ordinary sailors. They were part of an experiment so bold that even Allied generals had doubted it months before. Could a flat-bottomed ship truly carry 30-ton Shermans and deposit them directly on a hostile beach under fire? Most thought it suicidal. The Germans thought it impossible. From concrete bunkers overlooking the Normandy coast, German observers strained their binoculars as the horizon darkened with shapes. They expected barges, troop transports, and perhaps inflatable rafts. What they saw instead made their reports stumble into disbelief. Armored silhouettes, emerging from the sea itself, crawling up the sand like metallic beasts born of the tide. One officer at Point du Hoc scribbled a note so incredulous that his superior dismissed it as panic. He wrote that the enemy's machines seemed to sail on the water and drive upon the shore without pause. Kriegsmarine Observation Log, June 1944. This wasn't luck. It was the culmination of engineering foresight stretching back to 1940, when a British evacuation at Dunkirk had revealed the terrible gap between sea and land. Conventional ships couldn't unload heavy armor without ports. The American and British engineers swore never to face that weakness again. Among them was naval architect Andrew Higgins, a stubborn Louisiana boat builder who had spent years designing shallow-draft craft for swamps and rivers. His creation, the Higgins boat, would evolve into the landing craft tank, a floating ramp designed to conquer geography itself. U.S. Navy Design Bureau Memo, 1942. In early prototypes, tanks broke through decks, water flooded the holds, and engines failed under shifting weight. The design seemed cursed, yet the engineers refused to quit. They reinforced the hull with welded steel plates, added ballasting systems to counter-roll, and mounted twin gray marine GM diesels producing nearly 450 horsepower combined. What emerged was a vessel 120 feet long, capable of carrying 3 medium tanks at 8 knots, and beaching itself in less than 4 feet of water. When the bow ramp dropped, the tanks could surge forward instantly. It was a mechanical bridge between ocean and battlefield. WWII Spring 1943. Trials in the Solent proved the concept. U.S. Navy Lieutenant Commander J.G. Lambert recorded astonishment watching a Sherman M4 drive off an LCT and climb a 15-degree slope without stalling. U.S. Amphibious Training Command notes, 1943. Yet still, German planners ignored the possibility. Their Atlantic Wall doctrine rested on the belief that tanks could not land without a pier. Their artillery zones were calibrated to destroy infantry before armor could arrive. Their calculations assumed that any armored threat would come through a captured port days after invasion. It was a fatal assumption on the morning of D-Day, as the LCT convoys neared Omaha and Gold Beaches. These doctrines unraveled. The German fire began at 6 o'clock, thunderous and chaotic. Shells ripped into waves, geysers of smoke towering higher than church spires. But the LCTs kept advancing. Their flat hulls rode over breakers, their armored ramps shielding crews from shrapnel. Hold course. A coxswain barked, gripping the wheel as tracer rounds hissed past like hornets. Inside the hold, tank crews waited in darkness, engines idling, exhaust fumes choking the air. One sergeant murmured through clenched teeth, "When the ramp drops, don't stop. Just go." U.S. Army After Action Report, June 1944. When those ramps finally dropped, history tilted. Sand sprayed beneath steel tracks as Sherman tanks rolled into surf still chest deep, water cascading off their hulls. Machine gun fire hammered the ramps, but the tanks advanced, turrets already rotating toward enemy positions. German gunners froze in their pillboxes. The Atlantic Wall was built to repel men, not machines that emerged from the sea itself. Inside one bunker near Colleville-sur-Mer, a German gunner wrote that the enemy's iron wagons swim through the water and defy our defenses. Diary fragment. Bundesarchiv. Behind this shock lay the logistical might of Operation Neptune. The Allies had constructed over 4,000 landing craft of different types by June 1944, a feat of industrial coordination that stunned even their own planners. U.S. factories from New Orleans to Pennsylvania worked around the clock to weld steel sections that fit together like a giant kit. Women riveters and civilian engineers labored through nights, their hands blistered but proud. Each completed LCT was a floating promise of invasion power. Higgins Industries Production Ledger, 1943. German intelligence had missed it all. Reconnaissance photos taken in England showed strange rectangular shapes lined up along rivers, but analysts classified them as ferry pontoons. Even when Allied training footage leaked through neutral press, Wehrmacht engineers laughed it off. They believed such a craft would sink under the weight of armor long before reaching shore. Their coastal defenses were a labyrinth of concrete, minefields, and obstacles, but none placed far enough into the tide to stop a craft that could drive itself onto land. The first hours of the invasion smashed that illusion. By 9 o'clock, at least 200 LCTs had landed across 5 beaches, delivering nearly 600 tanks to the front lines. On Utah Beach, General Theodore Roosevelt Jr. stood amid the wreckage and marveled that the sea has brought us our fortress. At Gold Beach, British Churchills crawled through surf and began blasting concrete casemates within minutes of touchdown. Each tank that reached dry sand was a miracle of engineering timing. Each minute of delay meant lives lost. Yet they kept coming, wave after wave. Through the smoke and thunder, Allied commanders realized they had unlocked a new form of warfare. No longer did armies need harbors or docks. The beach itself had become the harbor. This concept would rewrite the future of amphibious assaults forever, but in that moment, on that gray June morning, no one thought about strategy. They thought only of survival. Officers crouched in wet sand, watching their machines disappear into smoke, praying the next wave would make it through to BY midday. Radio channels filled with contradictory reports. Some units claimed total failure. Others declared victory. German commanders frantically tried to locate where the main attack was happening, but the truth was everywhere. Their defenses were being outflanked by an armada that didn't need ports, piers, or tides in their favor. The unthinkable was happening. The sea was delivering tanks, and as the sun broke through the clouds that afternoon, casting a pale light over the wreckage of steel and bodies, the Germans finally understood they had been wrong about more than just ships. They had misjudged the enemy's imagination. For behind every wave and every landing ramp was a mind that refused to accept the limits of war, because what the Germans witnessed that day was only the beginning. The real secret of America's amphibious power was still hidden, something deeper, more mechanical, and far more terrifying than they could yet see. The secret behind those miraculous beach landings wasn't luck. It wasn't even courage alone. It was the result of steel geometry, diesel rhythm, and the quiet genius of engineers who refused to accept the word impossible. To an untrained eye, the American landing craft tank looked crude, a floating box of bolts and fumes, but its design carried a hidden logic that would change warfare itself. The LCT was an amphibious solution to an ancient military riddle: how to bring the weight of land power across water without a port. Its hull was only half an inch thick at key points, just enough to hold buoyancy while carrying nearly 200 tons of cargo. Its secret lay in the hull's shape, a near-flat bottom, only a few feet deep at the bow. That shallow draft meant it could glide over sandbars, reefs, or mudflats where normal ships would choke and sink. The design records from the U.S. Bureau of Ships show hundreds of small adjustments tested in 1943, each one intended to make the craft die just a little slower and reach a little farther. The man who made that miracle possible wasn't an admiral or a general. He was a boat builder from New Orleans named Andrew Higgins. Before the war, he built wooden crafts for loggers to navigate swamp water. Those swamp boats, low and wide, could push against banks, unload, and reverse, all without docks. When the Navy first saw Higgins' ideas, they dismissed them as backwater improvisations. But when war came and the Allies realized their conventional ships could not land tanks anywhere without ports, those same maritime mules became their only salvation. Dwight Eisenhower would later tell an interviewer that Higgins is the man who won the war for us, not because he fought on the front, but because he made it possible to bring the front anywhere. The earliest prototypes of the landing craft tank were disasters. When the first Sherman tank drove aboard during tests off the coast of Florida in late 1942, the deck split. The hull filled with seawater, and the craft capsized. Engineers refused to quit. They welded the seams with thicker steel, reinforced the keel, and distributed ballast tanks evenly along the length. What emerged months later was something neither ship nor barge, a strange hybrid capable of carrying 3 medium tanks at once and beaching itself on 4 feet of water. It could run aground, release its cargo, and then reverse under its own power to reload. The concept was ugly, but it worked. By 1943, the Allies were testing the craft in full-scale amphibious rehearsals. At Slapton Sands, British and American crews learned through blood how difficult timing these assaults could be. Engineers recorded fuel ratios, ramp angles, and ramp release speeds. One commander's report from those trials noted in frustration that our men must learn to ride the sea like the enemy rides fear. Those tests revealed every weakness before Normandy arrived. When D-Day came, the LCT became the linchpin of the invasion. At 6:30 that morning, they approached Omaha, Utah, Juneau, Sword, and Gold. Underneath their decks, engines howled, twin gray marine diesels pushing 900 revolutions per minute, producing 450 horsepower combined. Each one burned through a gallon of fuel every few minutes, black smoke belching into the gray sky. The crews inside could barely breathe. Yet those engines gave life to something no fleet had ever achieved: the synchronized landing of tanks on open beaches. Across the water, German coastal artillery opened fire. The shells shrieked across the horizon, detonating around the convoy. Crews ducked under steel hatches as fragments sliced through the air. Some LCTs were torn apart. Others kept pushing forward, guided only by compasses shaking from impact. Inside one craft, a lieutenant yelled to his driver, "You get that tank rolling the second the ramp drops, or we die in here." The driver nodded, clutching the ignition lever like it was his last prayer. Moments later, the ramp clanged open, and the tank roared forward through seawater, climbing into smoke and flame. German spotters watching from the bluffs thought the sea itself was spawning tanks. The Wehrmacht had no answer. Their defensive manuals still assumed that heavy armor required ports, cranes, and docks. No training, no doctrine, and no mathematics in their coastal defense equations accounted for the idea that enemy tanks could roll directly from the surf into their gun nests. Field reports later captured by Allied intelligence described German officers refusing to believe what they were seeing, claiming it must be floating fortresses or even deceptive pontoons. But it was no trick, it was a factory-born truth. Behind that truth stood an army of engineers and workers thousands of miles from the front. In the factories of Higgins Industries in New Orleans, over 20,000 men and women worked day and night. Steel came in by rail and was cut, welded, and shaped in a rhythm that never stopped. Each LCT was built from prefabricated sections small enough to fit on flatbed trains, then assembled in British shipyards like a puzzle. The result was speed. A new LCT could be built, shipped, and launched in under a month. That production tempo stunned even naval strategists who had once doubted the concept. It was not just warfare. It was industrial art. One of the most dramatic tests of the LCT's value came weeks after the initial landings. At the Battle for Cherbourg in late June 1944, German resistance in the port city was fierce. The Allies needed armor inland, fast, before the enemy could reorganize. The port itself was heavily mined and unusable. The only way forward was to land reinforcement tanks directly on the beach again, under fire. In that operation, dozens of LCTs made repeated runs across the channel, sometimes 3 in a single day. Pilots called it suicide duty. Yet they went, navigating through shifting tides and artillery strikes. They brought in over 1,000 tons of tanks and supplies, keeping the momentum alive when logistics should have collapsed. German documents recovered after the war paint a picture of disbelief. Coastal commanders had filed repeated warnings to Berlin claiming that the enemy was operating an amphibious mechanism of unknown capacity. Some suggested the Allies had invented self-propelled pontoons. Others argued that it must be an illusion created by smoke and chaos. No one in their chain of command accepted the truth until it was too late. Their carefully calculated Atlantic wall, built over 4 years at immense cost, was undone by boats designed for swamps. Even after the beaches were secured, the legacy of the landing craft continued. Engineers modified them to carry fuel, ammunition, and even bulldozers. Field mechanics discovered that by welding steel planks to the ramp edges, they could create temporary docks. The very tools that delivered destruction now sustained the rebuilding. Every ramp drop became a heartbeat of logistics. Every craft a moving artery feeding the Allied advance. German intelligence eventually admitted in their internal reports that the enemy's mastery of amphibious transition was the decisive factor that made Fortress Europe indefensible. And yet, this wasn't the end of the story. Because behind the humble LCT lay a deeper secret, an innovation that tied every landing craft, every ship, and every tank into a single invisible web. It wasn't made of steel or smoke. It was made of something far more intangible: communication. What the Germans failed to understand next would prove deadlier than any tank or ship: the Allies' unseen power to talk, coordinate, and move as one mind across sea, land, and air. That hidden network was about to turn the tide of the entire war. By the time German headquarters realized what had struck them, the beaches of Normandy were already alive with steel. Within 48 hours, nearly 5,000 Allied vehicles had rolled ashore. What terrified the German command most was not the number of tanks, but the ease with which they arrived. Their defensive equations had crumbled, and the entire Atlantic wall, their proud illusion of invincibility, was eroding under the weight of American engineering. Reports from German coastal batteries spoke of unstoppable waves of iron, a phrase that haunted post-war interrogations conducted by the Allied Psychological Division. The interrogators noted how disbelief gave way to fatalism. Officers admitted that once they saw tanks coming straight out of the surf, they no longer believed reinforcement was possible. The shock was not just tactical, it was existential. An army that prided itself on order was watching chaos march inland with perfect coordination. That coordination came from more than courage. In the weeks that followed D-Day, Allied communications networks stretched across the channel like veins of light. Every landing craft carried radio sets tuned to a vast grid of frequencies linking ships, artillery, and air cover. Navy dispatch logs reveal entire convoys redirecting mid-voyage based on real-time orders. It was as though the invasion fleet possessed a shared nervous system. While German units shouted over field phones and messengers, the Allies spoke in wireless harmony. This unseen web transformed the landing craft from mere transport to part of a living organism of war. Psychologists later described the effect as technological morale. Soldiers trusted the machines that brought them to battle because those machines had already conquered nature. When you have watched your tank drive out of the sea itself, the impossible begins to feel routine. Interviews recorded in 1945 show soldiers describing the LCTs almost affectionately, calling them angels of steel and floating bridges of hope. In contrast, captured German troops spoke of iron ghosts, claiming that each craft that appeared through the smoke felt like a nightmare that refused to sink. Strategically, the consequences were enormous. The LCTs turned every beach into a port. By late June 1944, the Allies had landed over 500,000 tons of supplies without capturing a single deepwater harbor. Engineers used the landing craft to ferry prefabricated pier sections, fuel drums, and even locomotives onto makeshift docks. British planners later wrote in their operational review that the beach itself became our harbor, the tide our timetable. The Germans, still clinging to the belief that ports defined invasions, found themselves fighting an enemy that had redefined geography. That realization shattered morale all the way to Berlin. Intercepted messages between field marshals show growing despair. "We cannot fight a power that brings factories to the sea." Those factories were the Allied shipyards in miniature. Every LCT, a mobile production line delivering weapons, fuel, and men faster than destruction could consume them. German intelligence, once meticulous, became chaotic. Reports contradicted each other because the front itself was no longer a line. It was a flowing current. Behind this industrial miracle stood ordinary workers thousands of miles from the fighting. In New Orleans, welders worked in temperatures so high that molten sparks burned through their overalls. In Philadelphia, women stood beside enormous presses forming steel plates for hulls that would soon cross the Atlantic. The Office of War Information documented these scenes for propaganda films, showing mothers and sisters building the vessels that carried sons and brothers to victory. The home front and the front line had merged through the landing craft's existence. Technicians and field engineers also became unsung heroes. On the beaches, they repaired ruptured hulls with portable welding rigs, sometimes knee-deep in seawater under enemy shell fire. Maintenance teams learned to replace engine belts using parts scavenged from wrecks. Their improvisation kept the landing routes alive even when enemy aircraft turned the coastline into a graveyard of twisted metal. Later reports credited these repair crews for sustaining operational tempo at critical moments when reinforcements were thin. As the Allies advanced inland, the lessons of the landing craft evolved. Portable pontoons, amphibious trucks, and modular bridges all borrowed from the LCT's principle. Momentum mattered more than fortification. Generals began to think not in terms of territory held, but in time saved. Logistics officers called it war at the speed of arrival. In post-war debriefings, German strategists confessed they had never considered mobility itself a weapon. Now they understood that the enemy's greatest strength was not firepower but motion. When victory came less than a year later, historians tracing its roots kept returning to that gray morning in June 1944 and to the ungainly craft that carried armor onto the sand. During the U.S. Strategic Bombing Survey of 1946, analysts concluded that the decisive factor of the Western Front was amphibious continuity, the ability to move seamlessly from sea to land. Even air power and artillery, they argued, would have been useless without that mechanical bridge, but the psychological legacy ran deeper than strategy. Survivors on both sides carried images of those landings for the rest of their lives. American veterans spoke of a strange serenity in the chaos, the rhythmic clang of ramps dropping, the thunder of engines, and the feeling that technology itself was fighting alongside them. German survivors remembered the sound differently, the grinding roar of metal on wet sand, heralding defeat. One prisoner of war later told an interviewer that the sea had joined the enemy. In the decades that followed, the principles born on those beaches became doctrine. The U.S. Navy and Marine Corps expanded amphibious design into a science. Post-war vessels like the landing ship tank and later hovercraft traced their lineage directly to Higgins's vision. During the Korean War at Incheon, during Vietnam's riverine campaigns, and even in the Gulf War's prepositioned forces, the echo of 1944 persisted. Military engineers continued to chase the same ideal, to make the ocean a road instead of a barrier. Culturally, the LCT embodied a new philosophy of warfare. It blurred the boundary between soldier and engineer, between battlefield and factory. Historians now describe World War II not only as a clash of armies, but as a collision of industrial imaginations. Germany built fortresses. America built movement. And movement, in the end, proved the stronger fortress. By the late 20th century, the humble landing craft had all but disappeared from service, replaced by sleeker machines. Yet in every modern amphibious operation, from humanitarian relief to armored assault, its DNA remains. The modular ramps, shallow drafts, and prefabricated hulls of contemporary ships are quiet tributes to those wartime innovators who transformed shipyards into weapons. Today, rusting LCT hulls still lie buried in sand along the French coast. Fishermen sometimes find fragments of their steel bones washed up after storms. Museums preserve a few intact, their decks scarred, their ramps dented where Shermans once thundered forward. Visitors who climb aboard often remark on how small they feel, how ordinary the craft appears. That ordinariness is deceptive. In its simplicity lies one of history's most profound shifts, because the landing craft was not just a boat. It was a statement that human ingenuity can erase the line between sea and shore, between fear and advance. It proved that the imagination of a swamp builder could outthink an empire, and that courage multiplied by engineering could alter the fate of continents. As one veteran told a historian decades later, "We didn't just land on the beaches that day. The beaches landed on history." And somewhere in the hush that follows those words, you can almost hear it again, the diesel growl, the crash of surf, the thunder of ramps slamming open, the sound of a new world being born from the sea.